So I have here the beginnings, or like 90% of my neural network. And here I have coffee in a My Neighbor Totoro mug. Yes. But anyway, so here is like 80-95% of a neural network that I wrote in Maple, but I previously wrote it in Python, and this runs, but for some reason its outputs don't get any better with time and training. And I've tried to tweak it, and I don't know what the deal is, because this I pulled almost verbatim from an example that I found on YouTube, which was also written in Python. So I don't know. That was really, really frustrating. And I couldn't figure out what was wrong, even though my code matched perfectly to the person who made the example, and they even ran theirs in the video and it worked. So I don't know. Because originally my training inputs was a much bigger matrix. It was like 10 by 10. And I was like, well, maybe that's the problem somehow. So I made it 4 by 4, including the training outputs. And that didn't seem to help either. So, because right now I have maybe 30 hours of Python experience, but I have probably 60 or 70 hours, maybe close to 100 hours of Maple, because it's the language that I use in my coding class. Excuse me. So I decided to just kind of rewrite it in Maple. So that was pretty straightforward for the most part. Because in this basic one in Python, I didn't use any like TensorFlow or Keras or anything like that, scikit-learn or scikit or anything. All it does is use NumPy for arrays and for random seed generation. And exponents, like e to the something. That was the only thing it was using NumPy for, and I can do all of those much more easily in Maple, because Maple is like an all-in-one. It's closed source software and it costs money, so all those things are already built in. They might be a little more difficult to call, but they're still there. But so I had my sigmoid to map everything to between 0 and 1. I had the sigmoid derivative, which I remade over here. I made them as functions. Send x to 1 over 1 plus, e to the negative x. Same thing with my sigmoid derivative. Just made a function out of it. And then I have to call these two packages to work with dot products and these other things, and matrices and transpose matrices. But otherwise it matches pretty closely. The synaptic weights went through this whole effort, having a randomly generated 1 over here, randomly generated 3 by 1, and then it being multiplied by 2 and subtracted by 1 so that it falls between 0 and 1, then it's random. But over here I kind of got rid of that and I picked 4 values, and then I multiplied them by 2 and subtracted by 1 element wise. So I got this. So if I can get this to run, then I'll go back and add this level of complexity where it's recreating a random one every time. But for now, I'm just going to leave it as is to make it simpler, less opportunity for error. And then the rest of this stuff happens in a for loop. So that's pretty straightforward over here. Not so straightforward in Maple, because Maple, obviously it has all the same type of capabilities: for loops, while loops, you know, all the same things that any major language has. But like over here it says for iteration and range, that means it's just going to run this whole thing however many times I say. You have to be more specific in Maple. So I can use a for loop, but I need to specify, not only do I have to specify values, but this I needs to be somewhere, if that makes sense. It's like saying, I gotta turn it on. You have to be explicit, like for I from 1 to 10, do what's the simplest way I could do it? I squared. And then just do. What? Oh, 2. I can't spell. See? But the I has to be somewhere in the part that's getting iterated. So I have to find a place for I to go over here if I want to use a for loop. So right now I have a while loop nested in a for loop. So the while loop is comparing my error values. My error is a matrix, right? And it's one matrix minus another matrix, and it's getting an error value, and it's using that to adjust the synaptic weights, the synaptic weights, and it should be redoing it over and over again until those synaptic weights become values such that the test output gets closer and closer to the true output. So I was using this and saying, well, I want to reiterate this as many times as possible until my error value is less than 50%, which is awful, but I really, like I said, I just wanted this to run before I'd start making it more robust. So I considered doing an I from 1 to nops E. That's the number of operators, which in this case is just the length of E, which is my matrix, or my error matrix here. So I'll say for every, like, E1 would be the first element of matrix E, E2 would be the second element of matrix E, etc., etc. And I wanted to run this while loop for each iteration. That was the kind of the best way I could think to do it. I could just omit one of these entirely, this for loop or this while loop, but I'm not sure. Again, if I omit my while loop, I have to find a place to put I. And I maybe have to specify I differently. It's like I can, instead of doing the length of E, I can do from 1 to 10,000, the number of iterations I want to cycle, the number of cycles I want to perform, how many times I want it to learn. So, but that has not been simple. So again, the question becomes, where do I insert I, like I have here explicitly for I from 1 to this, do this to I. But it's not really happening here, which is why I considered doing the while loop. But the while loop is difficult because I can't just say while this entire condition applies to a matrix, because that's a complicated thing to do. Like, that's me trying to say, I want to iterate this process until every input, every entry, every A sub I comma J of the matrix is this value or less. I could do that, but that's like a lot more complicated. But maybe we can try it. So let's get So let's see how we can call a specific element of that specific entry in a matrix. Indexing arrays, matrices. Maple doesn't have nearly as much documentation and resources as Python does, but you know, it's okay. So you can do M23. So M23, second row, third column, gives you 6. So you could maybe do MIJ. Or you can do it in brackets. I don't know what difference that makes. Okay, and this is where it makes a difference. So if I do a parenthesis 1, that gives you the first element in the first row. But if I do a bracket 1, that gives you the first row. Interesting. So I'll just first row, second element. So I can do E parenthesis E is, well, true output is a 4x1 matrix, and test output is the dot product of, yeah, that shouldn't matter. So let's do E1 comma I. So let's say for I from 1 to 4, because that's how many elements are going to be in E. It's 4 entries because I'm dealing with a 4x4, including the true outputs here, right? So we one from, for I from 1 to 4, I'll always do this. Should be 1 is less than 0.5 do. It's too early for this. So then I need to end both of these. Let's see what that does. I really don't expect it to work. Can I determine if this expression is true or false? E11 is less than 5. So maybe E is actually not a matrix. So if it's not a matrix, we can't call its elements as if they're in matrices. Doy. So let's see, let's work backwards. Excuse me. We have true output minus test output. Okay, that should be correct, but what form are those two? So test output is the sigmoid of the dot product, the input and the synaptic weights. Well, the dot product of the input and the synaptic weights it's been a long time since I gives a scalar, right? So it's just a number. So test output is going to give me the dot product of the input and the synaptic weights will be an integer value, and then taking the sigmoid of that, we'll just map it from 0 to 1. So in reality, this is a matrix minus the scalar, which should give us a matrix. Because true output's definitely a matrix, because I defined it explicitly as a transpose matrix. Test output should be a scalar value. Let's test it. I am busy. Stop yelling at me. So with linear algebra, it allows us to do just anything with a matrix. So I'll just establish it and call it X. So parenthesis, bracket, bracket. Let's do a 3 by 3. 2, 3. Close bracket, comma, open bracket, 2, 3, 4, close bracket, comma, open bracket, and then 3, 4, 5, bracket, bracket, parenthesis, semicolon. Okay. Missing operator. Yeah, I did it right. So what's the issue? Is it not supposed to have that? Missing operator. This is making me feel really dumb right now. Maybe I don't need linear algebra? Ah. Okay, it's got an ugly output. It's got a matrix. It's 3 by 3, and it says I comma j is 1, 1 comma 2 is 2, 1 comma 3 is 3. Okay. So that's the way we want to establish it. So cool. So now let's try and do x plus 1. So, okay, matrix 3 by 3. 1, 1 was 1 up here. Now it's 2. 1, 2 is 2. One ones. 1, 2. 1, 2 stayed the same. 1, 3 stayed the same. 2, 1 stayed the same. 2, 3. So the only value that changed was the row 1, column 1 value. That's really interesting. So what if I do x plus oh no, I can't do that because it's I could just establish a whole nother 3 by 3. Alright, let me reestablish x. Alright, then let's do x plus let's establish another matrix. Okay, so now we have y. So now let's do x plus y. So 1 plus 1 gave us 2. 2 plus 1 gave us 3. 3 plus 1 gave us 4. 2 plus 1 gave us 3. So it looks like that worked. So I guess I need to define the whole thing explicitly. You can't just do a matrix plus a scalar and know it applies to the whole thing, I guess. I don't know why I didn't just Google that. Add scalar to a matrix. What? I don't even know what that is. Oh, so you can do it. You just need the stupid package. Alright, so we have x now with alright, so x was 1, 2, 3, 2, 3, 4, 3, 4, 5. Now we have 2, 2, 3. What? So once again, it only does it need to be in brackets? I thought they were all parentheses. Two, 2, 3. Nope, that did not do it. Well, I know that I have it. was not 4. This was in 5. Taylor series. It's not 5. Maybe it was in 6. Come on. Big data. Writing external. Maybe it was 3. God. I should go back and label all of these. These are worksheets from class. I don't know where it is. Super annoying. See, I don't want to have to do it in 4 lines. That's just nonsense. Why is this so complicated? I guess if all else fails, I can just redefine it like this. Just gonna make all of this a lot more complicated than I feel like it needs to be. So I need to make a matrix, and like a 4x1, where that is the value. Well, no, I can't even do that because dot product again gives me a scalar like we said, and then the sigma 1 just gives me a single scalar between 0 and 1. So but that the synapse weights need to be adjusted differently, right? They don't all need to be adjusted by the same amount every iteration. The amount each one would have to be adjusted would vary depending on how much each one was off. So why it would have to be, you would have to specify each entry of the matrix. Well, then why is the test output? See, this is the issue that I keep running into, is that it seems that my code over here in Maple needs to necessarily continue to get larger because there's this other crap in it, and yet somehow this is 25 lines, 30 lines. Because over here, the outputs, it's all effectively saying the same thing. Test output is the sigmoid of a dot product of an input layer and synaptic weights. Well, that's a single value. The outputs error is training inputs minus outputs. So that means we're calling the error one thing when the error is going to be different for each synapse. It's too early for this shit. Which again, I'm either misunderstanding something or his code was extremely lucky in that it somehow happened to work despite being written kind of the wrong way, which that's really unlikely, you know, like how rare is it to write something the wrong way in code and still get the answer you're looking for? I mean, I guess maybe it's possible depending on how general the answer is that you're looking for, but if you're looking for something this specific, there's no way you can accidentally write it wrong, which leads me to believe that I'm misunderstanding something, but I feel like I have a pretty good grasp of the math. This is at most calculus 2. Well, even then it's really just algebra 1 because we don't even have to calculate the derivative. It's doing it for us, and it's using that to create our adjustments. Because even if we look at the adjustment, if we ignore the issue with E for the moment, if we look at adjustment, we're saying we're multiplying E, which should be a matrix, because it's going to be, the error value is going to be different for every entry. And we multiply the whole matrix by a scalar. But we can't multiply it by a scalar, or no, that'll be the derivative of test output. Well, test output is again a scalar value, but should it be? The whole point is to have synapse values adjusted independently. That's what I'm saying. Let's just run this. See, that didn't even do anything. That's weird. Let's try this one. I don't even remember what the difference was between these two. I'm going to change the script path. So the last time I ran these two, they both ran, but now they're not. Weird. I don't remember. I don't know, but it's looking like I'm continuously having to edit things in this, right? And I was like, yeah, I can totally keep it at 20 lines. But the more I see this, the more I look at it and find these issues, the more it's looking like I just need to start over. I need to write it out and just start over. I need to start from right here. I can keep these two things. They're very strange. They're just two functions. But all this stuff, this can stay the same. This can stay the same. And this can stay the same. So everything afterwards, I need to reevaluate whether it's in the proper data type. Not even data type, but just the form that it's in. I've spent so much time on this project. I originally did it in Maple. That was based on a worksheet that I found that's probably hasn't been looked at since 2013. Extremely long, extremely verbose, awful. And I was like, no, I'm going to do Python because everyone knows Python. And there's oodles of documentation. And then there were the issues of figuring out which tutorials and videos to look at, because there was a very specific problem I wanted to do, which was time series analysis. I wanted to predict the price of Bitcoin, which I know is extremely hard to do because there's a lot of noise. Signal to noise ratio is pretty high. But I just wanted a proof of concept, right? I wanted it to run and output numbers of some kind. But I couldn't find a tutorial or an example that was specific to that. So I was trying to find one that was similar, like time series analysis for a stock price. But I felt like right off the bat, the way those two things deviated made it so that my skill level was like not enough, because I don't know enough about machine learning and really Python in general to know how I need to adjust the code to tailor it to the particular thing that I want to do. So it was really frustrating to try and tailor an example. So I was like, you know what? I will find the simplest example that I can, and I will understand every part of it, which I felt like I did. With this stuff, the math is very straightforward. The sequence of events, very straightforward. And I was like, all right, I got a handle on this. So I tried to adjust things in it. It didn't help. I changed, things like the iteration and my synaptic weights and my random seed and the inputs and outputs. And it just, none of that worked. So I was like, you know what? I have the most experience in Maple. I'm gonna take this, and I'm just going to rewrite it in Maple. And now, at the very least, I can go to my professor and say, hey, can you help me with this? Because he's a Maple guru. Because he works with Maple a lot, and he writes very big projects and programs with it. So I don't know. I think I'm going to have to start over. The whole reason why I'm doing this is not just for fun, because this is not what I find particularly fun. Once upon a time, 4 years ago, I thought I wanted to be a CS kid. That's not the case. That changed after about a year. And I transitioned to math, but this is a project for another class. This is actually a project for my theory of computation class. I have a group project And we have to talk about neural networks, which is the topic that we chose, and their history, relevance, how they work under the hood and all this stuff. And then I needed to come up with a very basic example of one. And this is all made harder by the fact that classes are, of course, online now. And having a math class online is just a nightmare. But I think I'm going to start over. And I think I'll say that for next time. So, thanks for watching. See you later.